like to tell about the deep learning model for smart manufacturing using convolutional LSTM neural network autoencoders. Then we are going to see about the overview of our process. Smart manufacturing integrates big data, advanced analytics, high performance computing and the industrial Internet of Things to manufacturing systems and industries to improve manufacturing processes, resulting in better quality products that are available at lower cost. By using time series forecasting, it is applied to many areas of smart factories, including machine health monitoring, predictive maintenance and production scheduling. The model comprises a big convolutional LSTM, that is long short term memory encoder decoder architecture. LSTM autoencoder architecture has been proposed for machine speed prediction in a smart manufacturing process. In our process, the main objective is to detect the machine speed prediction in a smart manufacturing process. Then we have to implement the autoencoded for comprising the raw data and to enhance the deep learning algorithm such as long short term memory for better performance and to enhance the overall performance. Finally, the experimental result shows that some performance metrics such as RMSE, MAE, MSE and SMAPE, that is RMSE root mean square error, mean absolute error, mean square error and symmetrical mean absolute percentage error. So this is the overview of our process. Then we are going to see about the flow of our process. First we have to take the data set, that is the industry data set. We have to take the input data from the data set. After that we have to implement the pre-processing step. In this step we have to handle missing values, label encoding, then normalize or scaler. Handling missing values means we have to check any missing values is present in our input data. We have to replace the missing values by zeros or non-values. The purpose of handling missing value is for to avoid the wrong prediction. After that we have to encode the label encoding to encode the data into labels. Finally, in this step we have to use a normalize or scalar process. The normalization means it is a pre-processing library which contains the normalize function to normalize the data. After that we have to implement the data splitting. The data splitting is the act of partitioning the data, that is it is the data splitting into test and train. The test contains the smaller portion of our input data, train contains the most of our input data. After that we have to implement the auto-encoded model. In this model it comprises the raw data by using encoded the input data and again the decoded the input data. So the purpose of auto-encoded is comprising the data. After that finally we have to implement the classification algorithm LSTM, long short term memory. Under LSTM we have to find some performance metrics, that is MAE, MSE, symmetrical mean absolute percentage error. So this is the flow of our process. Now we are going to see our output part. We are running our process in Spider IDE from Anaconda Navigator. Yeah, just our process is on running. Once I run our process, I will explain the output part. Test is on running. Yeah, our process is successfully run. Okay, just I will explain one by one. Yeah, this is our input data, that is a data selection. I have just displayed some sample of inputs from our input data. Just I have displayed some 10 rows. Okay, so this is our input data set. Next we have to implement pre-processing step. Right, in pre-processing we have to implement the checking missing values. Yeah, here 0 displayed. The 0 means there is no missing values in corresponding attribute. So in our data set there is no missing values. So if there is any missing values, we have to replace the missing values by zeros or non-values. After that, training the samples by using the auto-encoded process. Just it is the process for auto-encoded. After that, this is for LSTM. That training our sample data and validating the sample data by using the LSTM. By using LSTM, we have to find some performance metrics: mean absolute error, mean square error, root mean square error, symmetrical mean absolute error, percentage error. So these are the error values, that is for time series forecasting. Finally, we have to evaluate the graph for test and training. So this is our output. Thank you.